Hi there everyone, welcome back to the channel. I'm the GCSE science teacher. In today's video, we're going to be talking about electric motors for GCSE Physics students. So if you do find this video helpful and you'd like more content like this, please let me know by giving the video a thumbs up, share it with someone else so they don't miss out on key revision, and also please do subscribe and join this lovely community. Thank you so much to everyone who has subscribed and has just been really lovely and left nice comments and just helpful suggestions, or maybe even asked for certain types of videos on GCSE biology, chemistry and physics. It's always great to hear from you guys, so thank you so much for all of that. Let's get started. Let's talk about electric motors. Now, first of all, what even is an electric motor? Well, you've probably heard of it before, but you might not know exactly what it is. It's a device, and essentially what it does is it converts electricity into mechanical energy. So essentially, when you think of an electric motor, it's a device that moves, it spins, it rotates. And that is because of this idea of the motor effect, which we've talked about in previous videos on my channel. I'll link them for you in case you missed it. Subscribe and you definitely won't miss any future ones. But yeah, essentially that's what it is. The motor effect, remember, is just when a coil of wire that's carrying a current, the flow of charge, in a magnetic field experiences a force, and that leads to that rotation. So some of the ideas we've talked about in previous videos are things like solenoids, which is just a coil of wire that has current flowing through it, and that can form a typical bar magnet shape in terms of the magnetic field, as you can see here. We also have electromagnets that have a solid iron core. This is a very simple one with an iron nail. Again, electricity and magnetism very much interlinked. So these are essentially the ideas that build upon this topic and then talk about the electric motors. So we're going to discuss this further, especially with regards to Fleming's left-hand rule, which we'll just cover now. So with Fleming's left-hand rule, remember you're going to use your left hand to do this. Your thumb always is representing the movement. The first finger is the field, the magnetic field specifically from north to south, remember? And then your second finger is the current, the direction of flow of charge from positive to negative. And these concepts I have discussed before, like I said, I'll link those videos for you guys, but you want to make sure you're using your left hand to do this, and you want to make sure you are able to orientate your hands and digits in a certain way so you can actually understand what's going on. So I'll give you an example now. So how does the electric motor actually work? So the first thing you want to know is this is the typical piece of experiment apparatus setup that you'll see in the exam. So this is just a piece of wire that's going into the page. So that's what's happening in this way. I know it looks like it's upwards, it's just the way it's drawn, but imagine it's going into the page away from you. Okay, so what you need to do to know how the electric motor will work, you'll know that it will rotate because the motors rotate because of the motor effect. But how does it do that? And also you may be asked to know which way the motor will rotate as well. So we'll discuss this now. So you want to make sure you know that your left hand, like I said before, Fleming's left-hand rule, you've got your digits in the right orientation, all at right angles to each other. With this electric motor, you can see we've got two bar magnets either side of the wire, which is that black line carrying current. So we know there's going to be some sort of motor effect going on here. We know there's going to be some rotation. Now, as you can see, on the right-hand side of the wire, we've got a positive terminal. It's going into the page and then back out through the negative side as well. So that flow of charge is essentially flowing around the wire, as we see here. Now, I've put a little star on the apparatus setup to discuss what's happening at this part of the wire, because at different parts of the wire, of course, you're going to have different things going on. You're going to have different orientations. So I think it's important we just talk about one specific place. So the star is where I'm referring to. So the first thing you want to do is put out your left hand in the formation like this, as Fleming's left-hand rule. And you want to see that the field is your first finger. So you want to point it in the direction north to south. So we can see that it's going from the left to right direction. So we point it this way. The second finger is the current. So currently, the second finger is pointing towards myself. However, in the diagram, it's actually the wire is going towards myself as well, because you can see it's going from positive all the way around and then negative. So the Second finger needs to point outwards, so I can keep my hand the same as this. Okay, it looks like this, but I'm just pointing this way. And then what we want to do is we want to see where our thumb is. So as you can see, the thumb, the movement, that force that's being experienced on that wire is actually moving upwards, which is why the wire you see here is actually going to move upwards, and it's going to start to have a clockwise rotation. Now, the thing is, with this apparatus setup, there's one thing I didn't mention, and this is the bit at the bottom called the split ring commutator. And essentially what this does is it transfers that DC, that direct current, and it actually changes the direction every half a turn. So it causes a continuous rotation. Because as you can see, as soon as that rotation happens, the current is, it's not going to move any further. It needs to constantly change so that the motor effect constantly helps with that rotation as well. So that's what the split ring commutator does. If you were to do the other side, so opposite the star, feel free to do this yourself. You can see the orientation is going to go downwards as well. So yeah, this is the sort of thing they could ask you to do using the Fleming's left-hand rule to essentially decide and work out which way the motor will move based on the apparatus setup they give you in the exam. But they could also ask you, what does the split ring commutator do? That's something they could ask as well. So I hope you did find this helpful. So it was a bit of a quick one today, but if you would like any more support or help with any of this that I've discussed today, feel free to drop me a comment in the comment section. I'm more than happy to get back to you guys. It's lovely to hear from you. Thank you so much for your support today. I've been the GCSE science teacher and you have been curious. Like I say, if you'd like any more support, I have an Instagram, a TikTok where I do post helpful hints and tips. I also have lots of videos here on my channel in playlists as well. So I'll leave some here for you if you want to click on those. Do subscribe if you haven't already. It'd be amazing to have you here. Thank you so much for choosing to revise with me, and I'll see you in the next one. Take care.